The AN/SPY-6 isn't just a radar, it's the most advanced digital shield ever forged for the...
Let's explore the journey of this AN/SPY-6.
It starts with these gallium nitride crystals. For the AN/SPY-6, we need thermal conductivity that exceeds legacy silicon by a factor of 10.
Checking the substrate of the AN/SPY-6. If there's even one microscopic flaw, the whole wafer is scrapped.
This high-grade alloy will form the chassis for the AN/SPY-6 radar modular assemblies. It's light, but tough as nails.
Prepping the raw stock for the AN/SPY-6 housing. We need a perfectly flat surface for the next stage of machining.
These fiber optics carry the heartbeat of the AN/SPY-6. We're ensuring near zero signal attenuation before they go into the backplane.
Gold is the standard for the AN/SPY-6 connectors. We need maximum conductivity in the harshest salt air environments.
The AN/S6 runs hot because it's powerful. This specialent is designed to wick heat away.
Precision application of TM is vital for the AN/SPY-6 thermal management. It's all about the interface.
These ceramic substrates provide the electrical isolation required for the AN/SPY-6 high-voltage components.
Cutting the main power veins for the AN/SPY-6. These bus bars have to handle massive surges without flinching. EMI shielding is non-negotiable for the AN/SPY-6. We're casting these shields to prevent internal signal crosstalk.
Titanium hardware keeps the AN/SPY-6 light and corrosion resistant. Every bolt is accounted for.
These magnets are critical for the AN/SPY-6 circulators, ensuring the RF energy only flows in one direction.
The radome of the AN/SPY-6 must be transparent to our beams, but strong enough to withstand a hurricane.
Using silver-rich paste for the AN/SPY-6 to ensure the best possible thermal and electrical path.
We use liquid nitrogen to keep our GaN growth chambers at the perfect temperature for the AN/SPY-6 wafer production.
The brains of the AN/SPY-6 reside in these multi-layer PCBs. The complexity is staggering.
Inventory check complete. All raw materials for the AN/SPY-6 are spec perfect and ready for the assembly line.
Dicing the GaN wafers into individual power amplifiers for the AN/SPY-6. Precision is measured in microns here.
Our throughput for the AN/SPY-6 is dialed in. These robots don't blink and they never miss a placement. Zero void soldering is mandatory for the AN/SPY-6. Any air pocket could cause a thermal runaway during combat.
Bonding the neural network of the AN/SPY-6. These gold wires are thinner than a human hair.
This is the heart of the system, the T/R module. Thousands of these will power the AN/SPY-6 array.
Hermetically sealing the AN/SPY-6 modules to protect them from the humidity of the Pacific Ocean.
Each T/R module for the AN/SPY-6 is individually tuned to ensure perfect phase alignment.
The salt air is the enemy. This coating keeps the AN/SPY-6 electronics safe from corrosion for decades. Moving heat is the name of the game for the AN/SPY-6. These copper sinks are the first line of defense against overheating.
Sculpting the Radar Modular Assembly chassis. This is the building block of the AN/SPY-6 architecture.
The AN/SPY-6 uses a complex liquid cooling manifold to keep the GaN chips at peak performance.
Building the power lungs for the AN/SPY-6. This unit converts raw ship power into stable energy for the array.
These FPGAs provide the massive computing throughput the AN/SPY-6 needs to track hypersonic targets.
Plugging in the fiber backplane. Data flows through the AN/SPY-6 at the speed of light.
The interface faceplate of the AN/SPY-6 must be perfectly flat to avoid beam squint.
Populating the RMA. Each of these boxes makes the AN/SPY-6 more powerful and resilient.
Every bolt on the AN/SPY-6 is torqued to exact specs. We track every single turn for quality assurance. If a coolant leak happens inside the AN/SPY-6, it's game over. This pressure test ensures we are bone dry.
Starting the 48-hour burn-in for these AN SPY-6 modules, we catch any infant mortality here, not at sea.
The AN Brush SPY-6 thermal profile is looking rock solid. No hotspots detected during full power cycles.
Constructing the skeleton of the AN/SPY-6, this structure has to support 37 RMAs while facing 100 knot winds.
Aligning the main faceplate of the AN/SPY-6. Any warp here would ruin our beamforming accuracy.
The first block of the AN/SPY-6 is in. Only 36 more to go for the V1 configuration.
Building the AN/SPY-6 piece by piece. It's like a high-tech Lego set for national defense.
This header supplies the entire AN/SPY-6 array. We're moving hundreds of gallons of coolant per minute. Managing the power distribution for the AN/SPY-6. It's a lean flow of energy from the ship's turbines to the array.
Integrating the data trunk for the AN/SPY-6. This is where all the RMA signals converge.
Testing the AN/SPY-6 subarrays. We're checking for mutual interference between neighboring blocks.
The D-Rex is the conductor of the AN/SPY-6 orchestra. It generates the precise waveforms for every pulse.
The brains of the AN/SPY-6 are getting installed. This hardware processes terabytes of data every second.
Uploading the latest beamforming algorithms to the AN/SPY-6. This software defines our detection range.
The AN/SPY-6 monitors its own health. These sensors will alert the crew before a failure even happens, eliminating RF leakage in the AN/SPY-6. We need every watt of energy pointed at the target.
Wiring the main power cabinets for the AN/SPY-6. We're talking about megawatts of peak power here.
These shock mounts will protect the AN/SPY-6 from the recoil of the ship's own guns.
Fitting the skin of the AN/SPY-6. It's the final barrier between the ocean and our sensitive electronics.
Keeping the AN/SPY-6 backend cool is just as important as cooling the array face.
Verifying the grounding for the AN/SPY-6, we need a clean path for lightning strikes and static.
Any dust inside the AN/SPY-6 waveguides could cause an arc over at high power.
Final wipe down for the AN/SPY-6. We want it looking factory fresh before the tests begin.
The AN/SPY-6 needs instant energy for high power pulses. These capacitor banks provide that punch.
The AN/SPY-6 has to hear a whisper in a thunderstorm. These LNAs are the key to that sensitivity.
Dialing in the phase shifters of the AN/SPY-6, this is how we steer the radar beam without moving the dish.
The AN/SPY-6 must stay exactly on frequency to avoid jamming and interference.
This console gives the operator a window into the AN/SPY-6 soul. Every metric is visible here.
Precision splicing for the AN/SPY-6 data lines. Loss must be less than 0.1 decibels.
Ensuring the AN/SPY-6 is a sealed electromagnetic fortress.
The AN/SPY-6 weight must match the ship's stability model perfectly. Every pound counts.
Every part of the AN/SPY-6 is tracked in our digital twin database for lifecycle support.
Sealing the AN/SPY-6 for transport. We're moving from production to the test phase. Purging the AN/SPY-6 cooling lines. Humidity is the enemy of high voltage electronics.
Checking the service lights inside the AN/SPY-6. We make sure the sailors can see what they're doing.
Ensuring the AN/SPY-6 is running the latest combat certified software baseline.
The AN/SPY-6 is physically complete. It's a masterpiece of industrial engineering.
Moving the AN/SPY-6 to the range. Now we see if all that hard work pays off.
Setting up the AN/SPY-6 in the hush house. We need a clean RF environment for calibration.
The AN/SPY-6 antenna pattern is looking sharp. Side lobes are well within spec-perfect limits.
The AN/SPY-6 can shift its beam in microseconds. No target can outmaneuver this speed.
The AN/SPY-6 is holding steady at 100% duty cycle. The GaN modules are handling the stress beautifully.
Minimal mutual coupling in the AN/SPY-6 array. The isolation between RMAs is dialed in.
Clean power is essential for the AN/SPY-6. We're seeing zero ripple in the DC lines.
Latency in the AN/SPY-6 is near zero. Digital data fusion happens in real time. Balancing the AN/SPY-6 cooling flow. Every module gets the exact amount of chill it needs.
Testing the AN/SPY-6 failsafes. Safety metrics are just as important as performance.
We can troubleshoot the AN/SPY-6 from halfway across the world if we need to.
Preparing the AN/SPY-6 for its digital combat debut. The Aegis handshake is the final bridge.
The AN/SPY-6 sees right through the clutter. Only the real threats show up on the glass.
Tracking capacity for the AN/SPY-6 is massive. We're handling high saturation raids without breaking a sweat. Simulating 20 years at sea for the AN/SPY-6 modules. We're looking for any sign of corrosion.
Production on this AN/SPY-6 unit is officially complete. We're moving to Phase D for full-scale destruction testing.
Subjecting the AN/SPY-6 to extreme HIRF. We need to make sure external interference doesn't blind us. Locking the AN/SPY-6 onto a simulated ICBM. The range and resolution are unprecedented.
This is why the AN/SPY-6 exists. It's the only sensor that can reliably track hypersonic threats in the terminal phase.
The AN/SPY-6 just burned through that jammer like it wasn't even there. Our frequency agility is top tier.
The AN/SPY-6 is built for the fight. It stays operational even during a 50G shock event.
Instant-on capability for the AN/SPY-6, even in the dead of an Arctic winter. No warm-up required.
Testing the AN/SPY-6 seals against the jungle-like humidity of the South China Sea.
The AN systems can handle that bolt perfectly. Hardening the AN/SPY-6 against digital warfare. Our firewalls are as thick as our armor.
The AN/SPY-6 is silent, but it has to survive the roar of a flight deck. No vibration fatigue detected.
The AN/SPY-SC6 power conditioners are smoothing out the spikes. Total system stability.
Hot swapping an RMA on the AN/SPY-6, the system stays online and recalibrates automatically. That's true modularity.
Cleaning up the AN/SPY-6 beam. We're ensuring our energy is concentrated exactly where we want it.
The sensitivity of the AN/SPY-6 is mind-blowing. We're tracking small drones at ranges we used to need satellites for.
The sensor-to-shooter loop is closed. This AN/SPY-6 is ready for the fleet.
Safety first. We're mapping the AN/SPY-6 exclusion zones to keep our sailors out of the beam path.
The AN/SPY-6 doesn't sleep. We're proving the mean time between failure is better than anything in history.
Dry as a bone. The AN/SPY-6 sealing tech is worth every penny.
Multitasking is the AN/SPY-6's specialty. It's doing 10 jobs at once without a hitch.
The AN/SPY-6 has passed every test we threw at it. This unit is certified, mission ready.
Rapid.
Packing the AN/SPY-6 for its journey to the shipyard. We treat it like the national treasure it is.
We're protecting the AN/SPY-6 from the bumps of the road. Smooth transit is the goal.
The AN/SPY-6 is on the move. Next stop, Huntington Ingalls Industries.
High-value cargo coming through. The AN/SPY-6 is a top-tier strategic asset.
Air deploying the AN/SPY-6. We can get this tech anywhere in the world in less than 24 hours.
We've arrived. The future home of this AN/SPY-6 is waiting for us in the dry dock.
Opening the crate. The AN/SPY-6 looks perfect after its long trip. Quick health check before the big lift. This AN/SPY-6 is ready to be integrated. Steady now. We're about to marry the AN/SPY-6 to the ship's superstructure.
A 14-foot masterpiece of GaAs technology to express on the DDG-1 or 2.
Precision alignment. The AN/SPY-6 has to sit flush with the ship's skin for stealth and stability.
Locked in. The AN/SPY-6 is now part of the ship's hull. It's not going anywhere.
The AN/SPY-6 is now drinking from the ship's cooling system. Thermal balance achieved.
System energized. The AN/SPY-6 is drawing life from the ship's heart for the first time. Establishing the link. The AN/SPY-6 is now talking to the Aegis combat system. First light for the AN/SPY-6 on the DDG. Everything is looking green on my console.
The AN/SPY-6 now knows exactly where it is in the world. Navigation sync complete.
Tracking harbor traffic. The AN/SPY-6 resolution is so high I can see individual seagulls. Passing on the knowledge, these sailors are the ultimate users of the AN/SPY-6.
Heading out for the real deal. Sea trials for the AN/SPY-6 start now.
The AN/SPY-6 is at full throttle. We're scanning 360 degrees, out to the horizon and beyond.
Small boat detected at 50 miles. The AN/SPY-6 doesn't miss a thing on the surface.
Simulated engagement successful. The AN/SPY-6 provided a spec-perfect fire control solution.
Even in State 5 seas, the AN/SPY-6 beam stays rock solid. Mechanical and digital stability in action.
The AN/SPY-6 is a multitasker, defending the ship while managing our own assets. No jamming can stop the AN/SPY-6. We've got total spectrum dominance. The AN/SPY-6 is the eyes of the entire fleet. Cooperative engagement capability is dialed in.
Systems are nominal. The AN/SPY-6 is proving its world-class reliability.
Easy access, fast repairs. The AN/SPY-6 is designed for the sailor, not just the engineer.
Sea trials complete. The AN/SPY-6 passed with flying colors. We're ready for deployment.
Zero damage. The AN/SPY-6 housing is as tough as the day it left the factory.
Optimizing the AN/SPY-6 algorithms for the specific hull dynamics of this ship.
It's an honor to deliver this AN/SPY-6. You now have the best eyes in the Navy.
The AN/SPY-6 is officially part of the U.S. Navy fleet. Today, we become the shield.
Our first mission starts tomorrow. The AN/SPY-6 will be our primary sensor for the entire deployment.
Supporting the AN/SPY-6 wherever it goes. Our lean flow extends across the globe.
We've got a digital twin of this AN/SPY-6 running in our lab. We're with you every step of the way.
Haze gray and underway. The AN/SPY-6 is patrolling the seas, keeping our strike group safe.
The AN/SPY-6 is dialed in and ready for action. Mission accomplished.
From a single GaN chip to global maritime dominance,